Let's begin. Today is May 7th, 2024, and our daily Turing Machine Puzzle has 5 criteria cards and the 5 verification cards. But before we begin play, I want to show you the versatility of the board game Turing Machine. Once you purchase the board game, you have access to turingmachine.info, where you can actually generate and play a multitude of games. So the way you do that is you click on play, and here you have the choice of mode. In a previous video, I discussed the classic, extreme, and nightmare modes. Our daily puzzles are classic. Difficulty level are easy, standard, and hard. I believe that most of the daily puzzles are easy to standard. Hard uses an additional set of criteria cards that we generally don't see in the daily puzzles. And then you also get to choose the quantity of verifiers. So let's choose 4, and let's see what happens when we click generate. So as you can see, we have our 4 criteria cards, our 4 verification cards, and we have this unique identifier that in case you ever want to go back and review, we can search the database and it'll show us the puzzle. And I'll show you how to do that in the next video. But for now, let's actually go to our daily puzzle. And so today, we do have that 5 criteria puzzle with criteria 1, 13, 17, 19, and 20 using the purple verification color classification. So let's actually play. All right, so again, here are our 5 criteria cards. Top row A, B, C, bottom row D, E. And again, we're looking for a unique 3-digit code where each digit is between 1 and 5, but this unique code has to conform to the 5 criteria that we were given. And we're going to be proposing a potential solution. I start off with 314, and we're going to ask the Turing machine a set of questions, and it'll respond whether we're on the right track or not. And based on that information, we keep going. So our first criteria, A, compares the number, the triangle number, the first digit, and whether it is actually equal to 1 or is it greater than 1. Our criteria B compares our second and third digit, the square and the circle, and we're basically asking, is the square less than the circle? Are they equal, or is the square greater than the circle? Criteria C will confirm the quantity of even digits in our 3-digit code. Are there no evens? Is there 1, 2, or potentially all 3 may be even? Criteria D takes the sum of the first and the second digit, the triangle and the square, and compares that to 6. So is the sum less than 6? Is it equal to 6? Or is it greater than 6? And lastly, criteria E will differentiate between our 3-digit code and will tell us whether there are no repetitions, meaning all the digits are unique. Potentially, we could have a pair of digits somewhere within those 3 digits. Or could it be that it's all the same digit repeated? Okay? So as I stated, we have our initial proposal of 314. So let's see what we can do. So from what I see here, let me see how I can compare the square and the circle. So I'm going to choose criteria B. And so criteria B, the Turing machine tells me false. If I compare my proposal, my square digit is 1, my circle is 4. So the Turing machine is stating, no, it's not true that the circle is greater than the square. Since 4 is greater than 1, the Turing machine is telling me that is not correct. So if the circle is not greater than the square, then either it's equal or the square is bigger. So let's actually put that in our notes. So I'm going to put square and circle. And basically I'm going to state that either the square is greater than or equal to the circle. So again, it failed that the circle should not be greater. So that means that the square needs to be greater than the circle, or the square and the circle are indeed equal. So since we do have that possibility of them being equal, I'm going to test criteria E, since this one tells me whether I have a duplicate digit, or maybe they're all different. So let me test criteria E. Okay, that also failed, and which is okay. That just helps us eliminate a choice. So in this case, since I look at my proposal and I see that all of them are different, that means that's not correct. So that means no repetition is invalid. So either it's all the same, or I do have a pair. So for E, I'm going to write down that let's see, how can I phrase this? The 3-digit code, or the digits, or the code has a pair or are all the same. Okay, so we eliminated the possibility of them all be distinct. So that means the code has a pair or are all the same. Okay, so that stated, we could have pairs, but we haven't really eliminated anything. I guess, you know what? I guess, let's see. Could I have eliminated some possibilities here? No, I'm thinking that perhaps not, because of the equal, so I don't think I can actually eliminate anything. But at least we have an idea of what it should look like. All right, and that said, let me, what else can I choose? I think I'll choose D, just so that I have some information also on the triangle digit. So let's compare, or let's actually ask the Turing machine what criteria D will, how that'll help us. So D. Okay, so it is true, if I look at my proposal, that the sum is less than 6. So that is true. The Turing machine has confirmed that yes, the sum of the first 2 digits should be less than 6. So I will put that in D, that triangle plus square should be less than 6. Should be less than 6. Okay, so let's see, does that help us eliminate any possibilities? So I believe that if the sum is to be less than 6, neither of them could be a 5, right? Because if I were to say, at a minimum, pick, say, blue to be 1, square cannot be 5, because 1 plus 5 is equal to 6. And we need the sum to be less than 6. And vice versa, right? If square were to be as small as 1, then triangle cannot be 5. Anything else would also fail, right? 2 plus 5 is 7, so on and so forth. So the bigger we get on 1, the more impossible it is to get a 6. So I'm going to eliminate 5s from both of these. So triangle can't be 5 and square cannot be 5. But of course it could be 4, right? Because it could be 4 plus 1, right? That's 5, and 1 plus 4. So those are all still valid possibilities, and so are 2 plus 3 or 3 plus 2. So yeah, we can't eliminate the 1 and we can't eliminate the 4. Okay, so now that we have done our 3 Turing tests, we have to now assemble a new proposal. And so again, let's review what we've already established. We know that square needs to be greater or equal to circle. Okay, so as it is right now, we couldn't have 4 and 4, right? Because that sum is too big, or 3 and 3, as far as pairs go. And so let's see, what about this case that they're all the same? Well, yeah, I guess you could have all 1s, all 2s. Those are all okay for the sum and the equal. But let's also think about what we haven't established. Oh, this is interesting. Let's take a look at criteria A. That's saying that triangle is actually equal to 1 or greater than 1. So if it were greater than 1, like 2, 3, and 4, that means that triangle would have to be, not necessarily smaller, but we have to get it so that the sum is less than 6. So if it were 4, if it's anything but 1, we were kind of limited to what we could use, which could again lend itself to having a pair. And the other criteria of how many even. Okay, so again, if we're talking about evens, let's think about this. The only evens that we could have, at least in triangle and square, are 2 and 2. We couldn't have 2 and 4 or 4 and 2. So based on the number of evens, at least triangle and square would have to be both 2s. We couldn't have a mixture or even duplicate 4s. So let's see. And we're not necessarily guaranteed that we have to have evens here. We could have some odds. So let me try. I think if we kind of force a triangle to be slightly larger, that would kind of force square, to be a certain within a certain range. But then we also have to be concerned about circle here. So what can we say about circle based on what we have here? If they're equal, perhaps then maybe square is bigger. So maybe we could have 2, 2, 1 in case we do have a pair, 2, 2, 1, and we kind of force the circle to be 1. So let's try that. That'll be our proposal, 2, 2, 1. Okay, so let's test criteria A. Okay, so it is incorrect. If I look at my proposal, I chose triangle to be 2. Since 2 is greater than 1, that is incorrect. So in fact, triangle is actually equal to 1. So let us establish that fact here in my notes. I'm going to say triangle is equal to 1, and in I can eliminate then all of these values, everything but 1. So I can eliminate 2, I can eliminate 3, I can eliminate 4 and 5. Okay, And since triangle is one, square can still be any of those, right? Because one combined with 1 through 4, those all give us sums that are less than 6. So I can't eliminate anything from square. All right, and C, let's test how many evens we have. Okay, so it is incorrect to have 2 evens. So we know that we have to have at least 1 odd. And so since this is odd, these two cannot be both even, since the Turing machine just stated that we can't have 2 evens. So at best, we know that there is either no even or potentially 1 even. 2 failed, 3 is impossible because we know there's a 1. So in our notes for C, we will state that there is either no even or just 1. Okay, so again, the reason is 2 is impossible, right? Because that's what the Turing machine told us. Based on the fact that triangle is 1, that means that at best we have 1 even or potentially no even. Okay, so we do have one more item to test. Let's see. So we don't have to test A because we already know that for a fact. The sum, we already know that the sum is less than 6. So A and D are safe. So that means it's between B, C, and E. So we could verify whether, let's see. Yeah, we could test B and see which one's bigger between square and circle. Or we could, I'm leaning towards E to be a pair. It's kind of rare that they're all the same. It's not impossible, but it's rare. So let me see. B, D, yeah, it's either B or E. I think the one that'll be more promising is B, if we have the equal. All right, so let's go ahead and do B and see what that tells us. Okay, so it is also incorrect that square is greater than circle, so that would leave us that square must be equal to circle. Okay, so it failed where a circle is bigger and square is bigger, so they must be indeed equal. So let's actually update our notes and say that square is equal to circle. Okay, so we know again that we can't have 2 evens, so it can't be 4, 4, and it can't be 2, 2. So we can kind of eliminate at least those possibilities. So that means that we can have a mixture of them. So let's see. Can we, maybe we should start generating possibilities. So 1, 1, 1 seems to be a possibility. That sum is less than 6. They're equal. Oh, yeah, okay. So let's do that. So let's see. So we have 1, 1, 1. We also have 1. We can't have 1, 2, 2. So it's 1, 3, 3. Yeah, they're equal. Yeah, so those are the only possibilities. We already established triangles 1, square, and circle have to be equal. We can't have 2 evens because the Turing machine said no. And so the only possibilities are 1, 1, 1 and 1, 3, 3. So let's then confirm. Okay, so A and B work for both. Okay, I don't think there was ever a case where you could have an even here, or a single even, because that wouldn't be equal. They're all sums are less than 6. So the only thing we have is to actually test. We got to test one of these. And I'm thinking since 111 is so rare, I'll test 133. Let's see, is there any other clue that would help me? Yeah, because the only thing we did was to eliminate the repetition. Yeah, so let's test 133 and confirm. Yeah, enter your proposal 133, and again, I'm going to test E. Okay, yes, it's true that we do have a pair. Okay, so I think we've already kind of gone through all the possibilities. So let's actually go to the official Turing machine and enter our code. So test code, and it was 133. Verify. All right, fantastic, we got it. Now the question is, did we beat the Turing machine? So let's go back and gather our information. So we first tested BDE. BDE, and I believe D was the only one that was correct, yes. And then we had 3 fails, ABC, and then E at the end. So we got 2 more turns, or 2 more rounds, A, B, C, and then we had 1 in the 3rd round. So did we beat it? Well, we didn't beat it, we tied it, but based on the rules, if we tie the Turing machine, that's a win on our part. Okay, fantastic. Well, that does it for today. Thank you. Have a great one.